Let's try to find the antiderivative of tangent x plus 3, tangent of x plus 3. So this is not just tangent. This might throw you off, but you know how tangent x equals sine of x over cosine x, right? This is still allowed. So if we have tangent of x plus 3, you could still evaluate it like this, but you have to change what's in the inside. So instead of this equaling sine of x over cosine x, it would have to equal sine of x plus 3, sine of x plus 3, and then over cosine of x plus 3. So now we can rewrite it as sine of x plus 3 over cosine of x plus 3 dx. So we know that sine and cosine are derivatives of each other, so I'm going to try to cancel one of them out by making u substitution. So I'm going to make u equal cosine of x plus 3, and then du dx would be negative sine x plus 3, and then times dx. And the reason why that is say if we take the derivative, if we sub in u to be x plus 3, and then du dx would be, no, if you sub in, not u, sorry to confuse you. If we sub in some separate variable, like say if we had like t to be equal to x plus 3, and dt over dx would just be 1. So, yeah. And this should not be here. Alright. Now, I can multiply dx on both sides. So du equals negative sine of x plus 3 dx. And then I'm going to divide negative sine x plus 3 on both sides to isolate dx and then plug something in. So we get du over negative sine x plus 3. Or you could leave it like this. It's up to you. I just prefer to do this step, so it equals dx. So we have our u, so that's sine of x plus 3 over u, and then times du over negative sine x plus 3. So now they cancel out. So you get negative 1 over u du. And then when you integrate this, you get negative ln u. But now we have to go back into the x world. So this is the same thing as negative ln, absolute values on these, cosine of x plus 3, and don't forget the plus c. But you could also rewrite it as ln secant x plus 3 plus c, because remember, the coefficient is the exponent of the result. So cosine to the negative first power is just secant because they're reciprocals of each other. So either of these answers are fine. It's just, if it's a multiple choice, they'll probably use the second answer. But if you have it on free response, you can probably leave it like this answer. The integral of from 0 to 3 of x squared minus 6x minus 4 over x minus 8 dx. So let's see how we can approach this. if we it doesn't look like separating into separate integrals would work, like, for the most part, because basically, because if you had only this part right here, if you didn't have the x squared, you could do that. But since you have this x squared, it's a little sloppy. It doesn't look like you can use substitution because this top part does not have a factor of x plus 8. But I think there's another way to do this. So what I'm going to do is I'm going to use long division to see if this can simplify into anything. So x minus 8, and then x squared minus 6x minus 4. So x minus 8 goes into x minus 6x x amount of times. So when you multiply this out, so x times x is x squared, and then minus 8, x times negative 8 is negative 8x, and then we're subtracting this. So these x's cancel out. This 8x becomes positive. So you get 8x plus negative 6x. That's 2x. And now we got to bring down the negative 4. So x minus 8 goes into 2x 2 times. So when we multiply this out, so 2x, 2 times 2x is 2x, and then 2 times negative 8 is negative 16, and then we subtract that. So these x's cancel out, and then this negative 16 becomes a positive 16. 16 plus negative 4 is just 12. So you get x plus 2 with a remainder of 12. So you might be asking, how do you write that? We have a remainder of 12. Does that mean we can't do anything? Well, we can. We could just rewrite it as this. So we have the integral of 0 to 3 of x plus 2, and then since we have a remainder of 12, you add 12, and then you have the denominator. You basically divide it by the denominator. And now it actually makes it a whole lot easier because all of these we could easily integrate. So let's split it up into 3 integrals, one for each term. So 0 to 3 x dx, and then plus 0 to 3 2 dx, and then plus 0 to 3 12 over x minus 8 dx. So this would just be 1/2 x squared, because we have x to the first power, and then you're adding 1, that's 2, and then you divide by 2. And then you get 2x right here. Now for this, we're going to have to do a u substitution. So, and also it would be, we could bring out the 12. So, let's say u equals x plus 8. X minus 8, my bad. And then du over dx equals 1. So du equals dx. So I'm gonna rewrite it here. So I'm gonna bring the 12 out now. So, and then 1 over u du. But now we have to switch the limits because we did a u substitution. It has to be in terms of u, not in terms of x. So we basically have to plug in 0 to u and then 3 to u. So we get u1 to be, so 0 minus 8 is negative 8, and then you get u2 to be equal to negative 5. So we get negative 8 to negative 5. So let's just evaluate this part first, since we already know the answer. Going a little off topic. So basically it's just 1/2 3 squared plus 2 times 3, and then let's just say this is our a value. It's going to store it in an a value, and then we're going to do the same thing for 0, but we're going to have to subtract. So 1/2 0 squared plus 2 times 0, and then this cancels out, so we get a to be equal to, so that's 9/2 plus 6. So let's just keep that in mind. For now, so we're gonna have to bring that bring that up later, but I'm gonna focus on this integral right here. So basically we have the integral from negative 8 to negative 5, 12 over u du. I'm gonna bring the 12 out. So we get negative 8 to negative 5, and then we get 1 over u du. So that's just the same thing as 12 ln of absolute value of u, and then we're going to evaluate from negative 8 to negative 5. So we get 12 ln of negative 5 minus 12 ln of negative 8. So that's 12 ln of 5, and then 12 ln of 8, because you're just taking the absolute value, so the area exists. So you can condense this into a single logarithm, so we get 12 ln, and then we get 5 over 8. But remember, we still have our result from the previous integral that we evaluated. Remember our a value, so we're gonna have to add a, and a was 9/2 plus 6. So your final answer is 12 ln 5 over 8 plus 9/2 plus 6. Because we had to switch the bounds for the 12 over x minus 8. We had to switch the limits, so we did it separately, and then we evaluated the answer right here. But for x plus 2, we didn't have a switch of bounds, so we integrated them together, and that was our answer a. So make sure to don't forget